Alright folks, welcome to Unit 2. We're going to do our launch activity to launch into learning for Unit 2, which is also States of Matter Continued. So, in this launch activity, each lab group will use one paper, so make sure you write everyone's names on there. So let's go ahead and get started. It says, using this stuff, you are to determine the maximum number of pennies you can place in a film can and have it just barely float. That means, so if we add one more penny, it'll sink. So we're going to be asking you to determine and measure some certain things and then put that all together to make a prediction. Step 1, find the buoyant force on the film can. The way you find the buoyant force in the film can, it tells you all that over here on the graphic organizer. You know, you all can read, so we're not going to insult your intelligence. But basically, what you have to do is find out how much water a film can displaces. Now, we're going to be using our bigger graduated cylinders today. And you have two film cans. One's empty. Don't get that wet or that can mess up your measurements. The one that's got a heavy weight in it, that's the sinker. That's the one that's going to get wet. Or you might have this style of film can. The heavy one, that's the one you will put in the water. The one that's not heavy, has nothing in it, don't get it wet. Alright, so let's go ahead and let's very simply find out how much water it displaces. This is Archimedes' next big discovery. So we slowly lower it in so that the water only goes into the graduated cylinder and doesn't spill anywhere else. So we look at that and we get a number. And the number I'm getting is 40. So, here's the beauty of the whole thing. The buoyant force on the film can is exactly equal to the weight of the water that that film can displaces. So, we're going to go ahead and say, well, if it displaced 40 milliliters of water, then its buoyant force is 40 grams. That's pretty amazing, but that's true. Alright, so we write that in there. 40 grams is a buoyant force, and down here we write 40 grams. So again, I don't know what you'll get when you do them because they all vary somewhat, different sizes, but on this particular one I did, it was 40 grams. Next thing we need is how much does an empty film can weigh, so whatever kind of film can you're using, determine its mass, and we'll go ahead and determine its mass. Alright, so I get something like 5.6 on this one, so I write that in here next. 5.6. Now you're asked to get the mass of 1 penny. Well, you'll have a penny, but I'm going to use a dime just so we make you have to think a little bit. So we put a dime, you put a penny on. You could use a nickel quarter, you're going to use pennies, I'm using a dime. And we get the mass of that. So let's go ahead and get the... Okay, it looks like my dime has a mass of 2.2 grams. So a dime has a mass of 2.2 grams. I don't know what your penny will weigh. Maybe more, maybe less. Now, refer to your graphic organizer for assistance. If you forget what we're telling you, here's what you're going to have to do. Okay, lab group prediction. The maximum number of pennies the film can hold and still float is, you have to predict that. Here's how you predict it. You have to make it so that the total weight of this film can, the empty one, plus the weight of the pennies you're going to put in it is just barely under 40. So here's how we go about doing it. The weight of the film can is 5.6 grams, at least mine is. 1 dime weighs 2.2, so let's say I put 10 dimes in there. So 10 dimes, 2.2 times 10, that's pretty easy. You just move a decimal point, that's 22. So if we had 10 dimes, that'd be 27.6. And we put them in there. Well, obviously, it's going to float. So, the total weight of that can plus 10 dimes would be 27.6. Well, I need to add more. Now, if I add another 10 dimes, that'd be 22 more grams. Well, that's going to give me 49.6. That would be too heavy, and they would sink. So I know it's going to be somewhere. I'm not going to be able to add 10 more dimes. I have to add maybe 5 more. Let's try 5 times 2.2. If you're having trouble with that, Mr. Calculator is always happy to help you. So let's go 5 times 2.2. That's 11 grams. So if it's 27.6 plus 11, That'd be 38.6. That's getting pretty close to 40. So I've got 5 more dimes. That's a total of 15 dimes that I could add. If I add another dime at 2.2, that'd put me over. So I would have to predict that the closest weight I can get to 40 and still stay under it is 38.6. And so I would predict here, again I'm using dimes not pennies, that it would be 15 pennies. And you double check your math again. So over here you can go, okay, the weight of the film can is 5.6 plus 15 times 2.2. So the total mass of 15 dimes is 33. That gives me a mass of 38.6. That's the biggest, that's the heaviest I can make that film can and not have it go over 40. So I would say 15 dimes. Alright, then when you have your prediction made, you just raise your hand or let me know, and I'll come around and actually test it. You don't test it, I will, so I'll take your film can. I will put the number of pennies or dimes in this case that you tell me you need. We'll put it in. I'll stick it in the water, and it should just barely float. And ladies and gentlemen, look at that. It just barely floats. If I would add one more dime, that would put it over the edge. And there we go, ladies and gentlemen. Now it's a sinker. One more dime made it so that its mass was greater than the buoyant force. So what's the point of all this? The point of this is that the weight of the water an object displaces, this film can displaces that much water. The weight of that water, which is 40 grams, is equal to the upward push, the buoyant force that water exerts on things. So as long as that film can weighs less than 40 grams, it'll float. If it weighs more than 40 grams, it'll sink, because Archimedes figured out that the buoyant force, the upward push on an object submerged in water, is equal to the weight of the water it displaces. And we can measure that. All right, good luck.